In this question, it is given that a particle moves towards east with a velocity 5. After 10 seconds, its direction changes towards north with the same velocity. The average acceleration of particle is. So first of all, just try to understand the question. A particle moves towards east with a velocity 5 meter per second. So normally we'll take this direction as nothing but north. This is nothing but south. This is east and this is west. So a particle moves towards east with a velocity 5 meter per second. So initially particle were moving along this direction with a velocity 5 meter per second. After 10 seconds, its direction changes towards north. Now its direction is changed in this way. Let's say that is equal to nothing but 5 meter per second. The average acceleration of particle is. So in question it is given that velocity, the magnitude of velocity is same, but the direction of velocity is changed. So we can find out the value of acceleration. We know that acceleration is nothing but change in velocity vector divided by time. So over here we need to find out the value of change in velocity, that is final velocity vector minus initial velocity vector divided by time. It is not just final velocity minus initial velocity, it is final velocity vector minus initial velocity vector, or it is not just the subtraction of final speed and initial speed, it is the subtraction of final velocity vector and initial velocity vector. So we know that a vector minus b vector is a vector plus minus of b vector. So we can write this is our final velocity vector, and we need to subtract from this velocity vector, that is initial velocity vector. So we can write this 5 vector minus this vector is nothing but 5 vector plus minus of this vector. So we can write this is equal to nothing but 5 vector plus this vector, or you can write this 5 vector plus this 5 vector. So this is going to give a resultant vector, let's say that is having a magnitude of 5 root 2, because we know that when two vectors are same magnitude and angle between them is 90 degree, so resultant is equal to nothing but 5 root 2. So we got the value of change in velocity, and as acceleration is change in velocity by time. The magnitude of change in velocity is nothing but 5 root 2 divided by time is nothing but 10. So we can write this as root 2 divided by 5 by 10 can be written as this can 1 by 2, or 1 root 2 over here get cancelled. So it is going to be 1 divided by root 2. And along with that, we can find out what about the direction of this acceleration. So this is the direction of acceleration. As we are taking this is nothing but our north direction, and this is nothing but our west. So we can write this is the direction of acceleration, that is northwest, because it is going to make an angle 45 degree over here, because the component of velocity along this direction and this direction is same. So we are going to get an isosceles triangle. So this angle will be 45 and this angle is also equal to 45. So it is exactly coming in between north and west. That's why we are writing the direction as northwest.